Morning, welcome to Pure Handbook 9, Lesson 10, Transformations. A little bit different today. This video I've actually recorded after the lessons. I started accidentally recording a little bit later in the lesson, so here it is from the start. Before we begin, we need to make sure that we're clear with all the different types of transformations from year 1. Whether it be a translation, a stretch or reflection, we need to make sure we use that technical language. So let's just go through what each of them are. So I'm going to start first with the ones that affect the y coordinates. So all these ones I've highlighted in blue here. Now, when it affects a y coordinate, we apply that function first and then there's some change that happens afterwards. So you put x into your function and then you're going to do something that affects the y. So that could be, if it's a translation, you'll work out f of x and then plus a number. So f of x and then plus 5 would mean you're going to move every y value up by 5. So the technical way of saying that would be a translation of 0, 5. It's a stretch if you're multiplying your function by some constant a. And we describe that as a stretch by scale factor a, parallel to the y-axis. Make sure you use all that technical language in the exam. And then finally, we've got, if we have y equals minus f of x, this is just simply a reflection in your x-axis. Your positive y's become negative y's, your negative y's become positive y's. When the change affects the y's, or when the change happens outside of the function, it does what you'd expect. So 3f of x, for example, would mean you're going to multiply all your y values by 3, as you might expect. Then we'll look at the transformations that affect the x's. So if you have, for example, a transformation such as f of x minus a, and the x minus a is all in the bracket, so you can see here it's not just an x in the bracket, it's x minus a now. Now when the change affecting the x's is going to do the opposite of what you might expect. So for example, if you see an x minus 4 in the bracket, that doesn't mean you take 4 from all your x's, it means you're going to add 4 to all your x's. So that would be a translation of 4, 0 in that scenario. Similarly with the y equals f of ax, so if you see f of 5x, so you've got 5x in the bracket, so it's no longer just an x in the bracket, it's a 5x, it's going to affect your x's, then you're going to stretch this by a scale factor of 1 over 5, or in general 1 over a. So if you see 5x in the bracket, you wouldn't multiply all your x's by 5, you would divide all your x's by 5, or multiply them by a fifth. And then finally with the reflections, then if you have x is 2, for example, well now that's just going to be the same as when you input minus 2 into your function. So all your positive x's become negative x's, all your negative x's become positive x's. That one is a little bit similar to what happens with the reflections for y's as well. So basically, if it's change happening inside that bracket, or if you think about it in terms of it's no longer just x inside that bracket, it's going to affect your x's and it's going to do the opposite of what you might expect. If it's outside of the function, so all the ones in blue for example, then it's going to do what you expect. It's going to affect your y's. Now in this section, how it differs from first year is that there's going to be multiple transformations. This first example, we've got y equals x squared, and we're going to show how it maps to the curve y equals 2x squared plus 3. So if we say let f of x be x squared, then firstly we're going to 2x squared. Okay, so we just still got to apply the rules of BIDMAS. So 2f of x would be 2x squared. And then to get to the plus 3, I then simply add 3. So in terms of function notation, this would be 2f of x plus 3. Now I need to describe what's actually happened to my x's. Sorry, what's happened to the x squared curve here. So just need to describe these transformations. The first thing that happens is I go x squared to 2x. Now that's a stretch of scale factor, I'm just going to be lazy and write SF, scale factor 2 parallel to the y-axis. And then what happens is I then add 3 to that 2x squared. So that would be a translation of 0, 3. Notice that both of these transformations affect the y's, not the x's, so they're both doing what you might expect them to do, okay? So 2x squared plus 3 means you are going to take your value of x squared, you're going to double it, and then you're going to add 3 to it. And then we've got a question, does the order matter? Well, let's have a look. If we added the 3 first, that'd be x squared plus 3. And then if I multiplied it by 2, I'd have to multiply the whole thing by 2, which would give me 2x squared plus 6. So, yes, the order does matter. What this tells us is stretching by scale factor 2 and then translating it 0, 3 is different, so you get a different graph if you translated it 0, 3 first and then stretched it by a scale factor of 2. So yes, the order definitely does matter. Example 2. I've got to give the details of the pair of transformations, so you've got a clue there. There's going to be 2 transformations that does this. That maps the curve y equals 2x squared plus 12x plus 18 to the curve y equals x squared. What this means is I'm starting off with this 2x squared plus 12x plus 18, and I need to describe how I would go from that graph to x squared plus 2. Sorry, x squared. Now, firstly, what I'd want to do is I want to take this 2x squared plus 12x plus 18 and rewrite it in a easier form to deal with. You can't really tell how you'd go from that quadratic 2x squared right away. You can't really say what that means to the graph if you take away the 12x, for example. So firstly, what I need to do is put it in complete square form. Mentioned on many occasions, completing the square is a very powerful tool. So we're just going to complete the square here. So just put in square brackets first because you've got a coefficient of x squared that's not 1. Should all be familiar with completing the square, so hopefully this is nothing new here. Remember at the end, just expand that square bracket out, so 2 times x plus 3 all squared. 2 times minus 9 is minus 18. Minus 18 plus the 18, well, that's just going to go. So all I've done there is just rewrite that 2x squared plus 12x plus 18. So now what I've got to do is think about, well, how do I go from y equals 2x plus 3 all squared? How do I then end up with it just being y equals x squared? Now the first thing I'd do is think about, well, if I've gone from 2 bracket x plus 3 all squared, well, I'd simply just divide by 2 first, okay? So just divide by 2 first, and then that would just leave me with an x plus 3 all squared. Then what happens is, at the moment, you've got x plus 3 in the bracket all squared, but then what happens is you've just taken that, instead of x plus 3 in the bracket, you've now just got x on its own, but then just squaring it. So essentially you've subtracted 3 from the x. But we need to think about this going the other way. So if you... Sorry, we do need to think... Sorry, we are going from that top to the end there. So going through those steps, the first step, we divided by 2. So this is a stretch parallel to the y-axis of scale factor 1/2. And then secondly, you've got a translation. Now think about if you had a graph of x plus 3 all squared and you've gone to x squared, you'd have a root at -3, but when you go to x squared, you'd have a root of 0. So it's moved 3 to the right. So it's the translation of 3, 0. And you could also think about, well, what happens if you went the other way? If you started off with x squared and you went to x plus 3 all squared, well, because that plus 3, it'd mean you have to move all your x's, you'd have to go 3 to the left, and then if you then times by 2, you'd have to stretch it by a scale factor 2. But we're going the opposite way here, so these are the steps we'd need to take. Example 3, we've got f of ln x, which I've drawn here, where you've got a domain of x is greater than 0, of course. It's defined as a function, so you know that your x has to be greater than 0, okay? Because it's undefined for x equals 0, it's undefined for any negative value. So x has to be greater than 0. We're going to sketch two graphs here, y equals 2f of x minus 3, and y equals the modulus of f of minus x. And we need to show where the graph meets or crosses the x-axis. What I'm going to do is just take you over to GeoGebra for a second, but then I'll draw them back on the OneNote file here. Now firstly, what I've got here is just my y equals natural log of x. The first question, I'm working out 2 natural log of x minus 3, or 2f of x minus 3 if you will. So when you're doing these multiple transformations, my key would be do them in steps. So don't just go straight ahead for the final one, do them in steps. So firstly, I'm going to just show you what 2f of x looks like. All that's happened here is your y values have been doubled. Okay, so remember 2f of x means just double all your y's, leave the x's as they are. So x equals 1 is still there, okay, as your root. But what's happened is, let's say if you take x equals 2, you can roughly see that's about y equals 0.7. Now when x equals 2, it's roughly 1.4. Then what we have to do is, so this is our 2f of x now, is then 2f of x and then minus the 3. The minus 3 is outside the bracket, so yet again, it's just affecting your y's. So what this means is if, yet again, we focus on that x equals 2, it was 1.4 before, now it's approximately minus 1.6. So all your y values, you're taking 3 away. Both of these affect the y's, they both expect what you're going to do. In terms of what this intercept is, so it's crossing the x-axis here. Remember, graphs cross the x-axis when y equals 0. We're going to go back to the OneNote page in a second, and we are going to find out what that y value, what that x value, what that root is going to be. The second question wants us to find the modulus of f of minus x. So yeah, again, start with your f of x. Firstly, we're going to do f of minus x because we're going to deal with the bracket first. So remember, f of minus x means all your positive x's now are going to be negative x's. So the asymptote still remains unchanged, okay? It's still got an asymptote here of x equals 0, because basically you're reflecting the line x equals 0. And also note for the previous question, both transformations affected the y, so your asymptote remained unchanged. So we just have this for f of minus x. So note that your root, which is positive 1 before, is now negative 1. But if you then want to find the modulus of f of minus x, basically anything below the x-axis now gets reflected, so it's just going to look like this. Let's head back to this page here to draw that up. So obviously in exam you can't just get out a GeoGebra file like I did. So I would recommend doing these graphs in stages. So we have this here. The only thing that we didn't do on the GeoGebra file is find that value here. Now, you could see from the GeoGebra file it was approximately between 4 and 5. Now, I can't just put, oh, it's roughly 4.5 or something like that in the exam. I need to find out what that actually is. So I need to set this equal to 0. Remember, f of x is natural log of x, so 2 natural log of x minus 3 equals 0. Rearrange this, you get natural log of x equals 3 over 2. And then what we do is take e to the power of both sides. So if I take e to the power of the left-hand side, so e to the power of natural log of x, that just equals x. Really important result to remember. And then I just have e to the power of 3 over 2 here. That's the exact value, and that's what you're going to need to do. Don't change this to a decimal, just write your exact value of e to the power of 3 over 2. Then we have our other graph, so again you saw what happened there. And it will just look something like this. So you just had a root there of -1. The final example, now in the live lesson, what I did was get everyone to have a go at this before I just went through the answer. So I'd recommend that you pause the video here, have a go at this question, and then unpause it and look at the answers. So I'm just going to show you what these graphs would look like, but just a little bit of feedback on what we do. So you won't always necessarily have a, y equals natural log of x, y equals x squared plus 3x, etc. Sometimes you might just get something that's, you haven't got the equation of, you just told this is f of x, show the different mappings of this graph. So in our first example, we got 2f of x minus 1. Now, note what this means, okay? So try and think about this in 2 stages. The 2f of x means you're going to multiply all the y's by 2. So you're going to multiply all the y's by 2, and then you're going to take one from every y. So here you have, let's say, a point of 2 minus 1 and 6, 4. Your x's, so it's not affected the x's, so your x's remained unchanged. Okay, so you've still got 2 and 6 for your x's. However, you've taken one away from, you've doubled every y, and then you've taken one away, so that 4 becomes an 8, take one away, you're going to get 7. That minus 1, double it for minus 2, and then take one away, you get minus 3. And also look at what happens with the origin. Your x is going to remain unchanged, so it's still going to be 0, but in terms of what happens to the y, well, you double 0, you're going to get 0, but then take one away, you're going to get minus 1. The next one, we've got x plus 2 in the bracket, so we're going to minus 2 from x. Okay, it's changing the brackets, doing the opposite of what you'd expect. So you take 2 from every x first, and then you're going to add 2 from every y. So you add 2 to every y there. So what you should find there is your a just becomes 0, 1, and your b just becomes 4, 6. Going for these other examples then, just ignore this bit at the bottom. That was part of something else. Look at your bracket first, so always think about what's happening with your x's first before you get into the y's. So f of 2x, now it's no longer just an x in the bracket there, so you're going to have to not multiply every x by 2, but you're going to multiply every x by half. Okay, so multiply every x by a half, or divide every x by 2, and then multiply every y by 4. And then finally, again, bracket first, you've got x minus 1 in the bracket, so you're going to add 1 to x, and then you're going to, because you've got a negative on the outside, you're going to either think of it as multiplying every y by minus 1, or just think of it as reflect in the x-axis. Okay, and you've got those ones there. So I hope you got them right. Please let me know if you are not sure on any of these, and I'll see you for tomorrow for the next lesson.